These are the notes for Unit 2, Day 10, and they start on page 28 of your note packet. So in the previous class, we talked about the product rule, right? Where we had two things that were multiplied together, and we needed a differentiation technique to work with that. And so now we're talking about, it might not be too surprising, but now we're talking about the quotient rule. We know that, especially from Unit 1, we deal a lot with rational expressions, right? Expressions that are fractions, and evaluating those expressions. In Unit 1, we were evaluating limits. Now we're evaluating derivatives. So I don't think it's too surprising that we had to start talking about, what we do to differentiate something that's a quotient. So our essential question today is, how do we calculate derivatives of quotients? So taking you through this again, right? When I say derivative, you think slope. And that helps with many things. It helps with when we have a graphical application, because we need slopes off that graph. Also helps when we are trying to write the equation of a tangent line. And then reverse that, when I say slope, you think derivative. Okay, so the quotient rule. Now, we kind of, in the last class, we did a little experimentation, right? We said, how do you deal with products? Can we just take the derivative and multiply the derivatives together? And we couldn't. We had to come up with this, u v prime plus u prime v pattern that seemed to work, and so that was what our definition was. The quotient rule is a little harder to see intuitively. So we're just going to show you what the quotient rule is. So we have the derivative of a quotient. So think about this, like look down here at the example, right? We're going to take the derivative ddx of u over v. So u is its own function, v is its own function. So looking down here in the example, u is 5 minus 2x cubed. So u is a polynomial of degree 3, so we can use the power rule when we differentiate that. And v is x squared plus 3, so when we need to differentiate that, again, we can use the power rule. So so these two, like the product, the u and the v could be anything. We could have cosine on the top and x squared plus 3 on the bottom, because we know how to differentiate cosine. Okay, but here's the pattern. So the pattern is on the top, it's v times u prime minus u times v prime. Now, if you look at this and switch these two, there's a reason why it's written like this, vu prime, and I'll get to that in a second. But if you switch these two and say u prime v minus uv prime, this is the same pattern as the product rule, but it has a minus instead of a plus. So to help you remember that, just remember that these two patterns, this numerator and the product rule, have the same uv pattern. The product rule has a plus here, the quotient rule has a minus here. And then we divide all of that by taking the denominator. We don't do anything with it, we just square it. Okay, so no derivatives in the denominator, notice. And so the way I remember this gets to the reason why I reverse these two things, is I think about a little saying to remember the top: low d high minus high d low. So that's why I reversed these two in the beginning of the quotient rule. So low d high minus high d low is one way of remembering it. The other way of remembering it is it's just the product rule with a minus sign. And then over low squared is what I say. So when I talk about low, we're talking about the denominator. When I talk about high, we're talking about the numerator, right? This is low v, function v. This is high, function u. So let's try this with this example. So we have, if f of x is the quotient, 5x minus 2x cubed, all divided by x squared plus 3, find its derivative, right? That's what this whole thing is a question right here. F prime of x equals, right? That is saying find the derivative or differentiate f of x. That's like a whole question, just in one little notation. Okay, so I need to set up low D high minus high D low. So low is this. So low is x squared plus 3. So that's my V. And my high is my U. So I just labeled them here. So low is x squared plus 3. D high means I look at the top and I take the derivative. So derivative of 5 is 0. Derivative of this is minus 6x squared. So minus 6x squared. So this is low D high minus. Now I need high D low. So here's high. High is the numerator, right? 5 minus 2x cubed. That's just high, right? You're writing it down. It's just a function. And then D low, taking a look at the denominator, differentiate that. That's 2x. So low D high minus high D low all over low squared. Okay, so we're done. If this were a free response question and I asked you to differentiate it, this is a viable answer. We're done. You don't have to do anything else with it. The tricky part comes in when this is a multiple choice question and you have to match up a correct answer, which is typically the type of problem that you will be asked. So we've got to simplify this. So I'm going to distribute the minus 6x squared and I'm going to distribute the 2x and we're going to combine like terms. All of that's algebra, right? So I'm going to kind of go a little faster here. So distributing the negative 6x squared gets us this, right? Negative 6x to the fourth minus 18x squared. Don't forget about the minus sign here, right? And so distributing the 2x with the minus sign, we're kind of, distributing the minus sign to the right and the 2x to the left. We get minus 10x plus 4x to the fourth. Now this is the super duper important part. We don't change the denominator at all. We don't FOIL this. Do not do that. They will always give you the denominator as something squared. So we don't touch the denominator. We're just working with the top here. All right, combining like terms, looks like I have 2x to the fourth terms. So I'm going to combine those and then I'm going to pretty much be done. So when I combine those, I get minus 2x to the fourth and then everything else just falls into place. So here's the derivative for the function f of x. Okay, so let's talk about quotient rule versus the power rule, because when we have rational functions like this, we know we can rewrite this. We've already done this problem actually by rewriting this and making it a negative power. And it works out to be the same. So when we have expressions that are real simple like this, a monomial on the top and a monomial on the bottom, and a monomial or single term expressions, we can rewrite it as a product, really, and in this case we don't even really have to think about it as a product. We can just do a straight power rule because it's just x to the power. So let's talk about this. So let's first do our quotient rule because that's our new thing that we learned. So low D high, right? The derivative of the top is 0 because it's constant. So low D high minus high D low all over low squared. This is, every time I say we never have to do something, there's always an exception, right? I told you in the last example, we never touch the denominator, right? We leave it as is. This is the one time that we would actually call this x to the sixth because it's easier to write. So that's the only instance where this would change from something squared to actually working it out. Okay, so this first portion is times 0, so we're going to get rid of that altogether. So the top is just negative 6x squared, and the bottom is over x to the sixth. We can simplify that, right? X squared and x to the sixth gives us an x to the fourth in the denominator. So this is I put the negative sign out front, right? It was on top in the first expression, and this next expression I just put it out in front. It means the same thing. I could even put it in the bottom. We just never do that. So 6 over x to the fourth. So there's our answer. That's our derivative. Now let's use the power rule. Okay, I say or the product rule, but it's really just the power rule because we have a constant on the top. So we have 2x to the minus 3, right? This is how we would have handled it a couple of days ago. All right, let's just do the power rule here. Bring the negative 3 down. Decrease the power by 1. Remember, 1 smaller than negative 3 is negative 4. So we end up with bringing the power there, making it a negative 6, and then x to the negative 4. Think about that. X to the negative 4 is x to the fourth in the denominator, right? So this is negative 6 x to the negative 4, which is negative 6 over x to the 4. We get the same answer. So when we have problems like this, really it's up to you to decide which way you want to do it. You want to use the quotient rule or you want to rewrite it and use the power rule. Totally up to you. Okay, so we did this with the product rule. We're going to do this with the quotient rule, right? We're going to look at the definition and use the definition symbolically. So we're going to look at this as using these, and for the product rule, we had Anna's rule, Anna's organizer, that helped you organize things, and for the quotient rule, we have Jace's organizer to help you organize things. So that's an extra video of students in the past that came up with neat organizers. Okay, so we're really relying on the definition here, right? Because we see all these U's and V's. They could be F's and G's. They could be, you know, H's and K's. I mean, they don't have to be U's and V's, but the pattern is the same. So I like to make an organizer. I like to make it into a table. So we're evaluating this when X is 2, right? So when X is 2, my function U has a value of 3, right? That's what this number is. U of 2 equals 3. My derivative U prime equals -4. My function V equals 1 there, and my derivative V prime equals 2. Okay, and that helps me organize just in my brain. It just it's helpful for me to see this in table form, and then I can just pick the numbers right off of this row. Okay, so I'm thinking low D high minus high D low over low squared. Okay, so here's the question. Let Z equal U divided by V. So now I know U is the high and V is the low because of the definition here, because of what they stated. Okay, so and then they go on to say that's the quotient of function U and V. Use the quotient rule to find Z prime of 2. Okay, so we know Z is U over V, right? We just stated that, I just rewrote it. Okay, now I can do my low D high minus high D low. It's just my definition, right? Low D high minus high D low. So low D high is low is V, D high is U prime. So V U prime minus high D low. U V prime. And again, you can remember that as the product rule with a minus instead of a plus, all over low squared, V squared. Now I can just grab my numbers. V at when X is equal to 2 is 1. Right, so I'm going to put that in for V. U prime is -4, U is 3, V prime is 2. I'm going to have to do a little math here. All over 1 squared. You know 1 squared is 1. You don't need that denominator. So what do we have in the top here? We got -4 minus 6. So -4 minus 6 is -10. So the derivative of function Z at 2 is -10. And like the previous class, I could also give you the information graphically, and you have to pick off the U's and the V's and the U primes and the V primes. So, you know, this is where really that saying at the beginning of the notes comes in handy, right? When I say derivative, you think slope. So we're picking off the slopes and the points again. And we're doing that. So here's our quotient rule again. We're doing that all at 8. So we're looking right there. Okay, we're looking right along that red dashed line, and we're picking off points and we're picking off slopes. So I'm going to just go ahead and now look, I have F's and G's now. Okay, and the question says let Q be F over G. Right, that's why this comes in handy, the low D high minus high D low. Because if you memorize the U's and the V's, you might get the positions mixed up, but low D high is unmistakable. We know low D high is GF prime. Okay, so I'm going to write that GF prime. So notice I'm writing it symbolically, right? I'm writing it with generic variables, and that's super important. It's almost like doing the organizer as a table, because you're giving yourself the opportunity to kind of internalize this using the variables that appear in the problem. Okay, so minus now high D low. High D low, right? We're looking back at this quotient here. High is F, D low is G prime. So I'm going to say F G prime all over low squared, all over G squared. Okay, now I can go ahead and pick off this stuff. So Q prime of 8, I need G of 8. So that's a function value. That's a blue dot. G of 8 is 2. F prime is a green slope, right? So I come up to F, I find this slope here. The slope looks like it's up 1, 2, right 1. So that's 2. minus, now I need an f value, function value on f. So it's a blue dot, right? I go to x equals 8, I go up to function f, that looks like it's 6. And now I need a g prime, so I need a green slope on g. So here's g, its slope is negative. I'm going to come back down here, I see this line here, and I'm going to go down 1, right 2, so that's negative a half. All over g squared. So g squared, function g, g of 8 is 2, so it's 2 squared. So there's my value. Okay, now this is super important. This is an answer. And I didn't mention this back on the tabular example, but if this is a free response, you can leave the answer just like this. You do not have to simplify it. I will, as the grader, I will read and see the numbers and give you full credit for correct answer. So you don't even have to do the math, which is super cool and a huge time saver. If it's a multiple choice question, though, you might need to. So, and these are very commonly multiple choice questions. So 2 times 2 is 4 minus a negative 3. So careful about that. Minus a negative 3. So that's plus, right? So I have 4 plus 3, which is 7. And then 2 squared is 4. A lot of times people forget the second negative and they'll look at this as 4 minus 3, which is 1. And that'll be a teaser. That'll be an option for an answer on a multiple choice. They like to tease you like that. So be careful about those negative signs. Okay, when we get to class, we'll work on our topic questions with more quotient rules, and then you'll start your con for the evening.